Dividing polynomials, long division and short division. Dividing polynomial by monomial, divide each term with polynomial. Okay, so this one is just saying, look, if you have an individual fraction, you can split it up into each part. Just remember that whatever the denominator is can't be 0. So if it asks for a domain, we'll have to keep that in mind, but I don't think it does on these ones. This is good if it's, I would say if it's a monomial down here, like it's a one individual part of the expression by itself, like we will see in the next problem. But once these are, once the denominator is some kind of binomial or trinomial, which we shouldn't see. Binomials we will see though. We could, but for this type, we're just looking at some kind of monomial in the denominator, like this one, okay? So what I'm saying here is that you could, if you wanted to, you could take this and you could split it up into 3 separate terms, because that's what having a common denominator does, right? Like we've seen in the past, we forced denominators to be the same, and then we combined it into one individual fraction. This one's one individual fraction that now we are going to separate into 3 separate fractions. Now it's always addition between because these ones are showing addition, so I guess not always, but in this case it's addition. So then what do I got? I got 15x to the power of 9 over 5x to the power of 7 plus 40x to the power of 8. But again, it's divided by the same denominator, 5x to the power of 7. And then I got 5x to the power of 7 over 5x to the power of 7. So right here, we look and we see, just focus on one of these at a time. So kind of like what I've done before, I'm just going to ignore all this garbage for now. I'll come back to it. I'm just going to ignore it for now. And I'm going to work downwards, okay? So from this fraction, I can see, I'm going to start with, I like to start with the letters. I'll do letters on this one. I'll do numbers on the next one. So I'm looking at the x to the power of 9 over x to the power of 7, okay? Now, if I divide those two, you could just do 9 minus 7 in the exponents, but I know that these 7 are going to become phantom 1s with 7 of those, and I would just be left with x to the power of 2. And this is in the numerator. Why is that? Because I have more x's in the numerator. Now, of course, you could say, well, yeah, just apply those exponent rules, do 9 minus 7, you get x to the power of 2. It's the same idea, as long as you understand that this x to the power of 2 goes in the numerator. If it was negative, it would go in the denominator. We shouldn't see any negatives right now. Then I'm going to do the numbers part of that, so that would be 15 over 5. It's really 15 divided by 5, which is just 3. So I end up with a 3 times x squared. That means also, right here, I don't really need the fraction line, okay? Now, could we need it for the other ones? We could, but I don't need it for that one. Okay, so again, now let's move to the next one. I said I'd do the numbers first on this one, okay? So this one is showing I got 40 divided by 5. Again, that's a straight calculation. That's just 8. It's positive 8, by the way, so I'm going to show it as plus 8. And then I will work with the variables here, x to the power of 8 over x to the power of 7, which is really x to the power of 8 minus 7, which is x to the power of 1, which I'm going to show just as x. But if you put if you want to put that phantom 1 there, that's fine. I'm just not going to show it. And now the final term here, I'm going to do this a long way, then I'll explain the shortcut, which doesn't always happen, by the way. So last one I did the numbers, I'll do the letters first this time. So I'm going to look at x to the power of 7 over x to the power of 7. This would be x to the power of 7 minus 7, which is x to the power of 0, and anything to the power of 0 is just 1. So I'm going to put the 1 there, and I'm putting it there specifically because with the numbers, you got 5 divided by 5, which is just 1. I don't need 2 1s there. I don't want to put it like that because then it looks like 11, even if you put the multiplication between those, by the way. But it's positive 1, and I kind of expected some fractions there, but we didn't have any, and that's okay. That's just our final expression right there. So yeah, in this unit, we're used to factoring this. This one can't be factored, so it is done. Video, so thank you. This, yeah, you could have said I'm going to factor out some well, it looks like 7x's, right? So x to the power of 7 and 5. Yes, thank you. That would have shown you that you could have just kind of canceled those out. Which one's easier? I don't know. This is the way that I'm used to doing it because I'm a math nerd. But I'm glad you saw that. You could have factored out a 5x to the power of 7 here, and that would have left you with this.